So, okay, we're really trying to understand how this S action's working in our exponential object, b to the power of a. So, supposing we have some theta, which is an E-type figure of b to the power of a, and we've already seen that this sort of corresponds to this arrow theta under arrow anti-transposed, which is an arrow from hom E comma blank times a to b. And so this is really what we're actually going to be computing, because this is the kind of thing we can get our hands on. We can really ask ourselves sort of what are the arrows from hom E comma blank times a to b. We can enumerate them, and then we can think of those as sort of corresponding to these E-type figures of b to the power of a. But then we want to understand what happens when we have an arrow S from E to V in the category C. And we want to know what happens when we do a kind of S action on a theta like this. So we've already talked about this kind of correspondence. When we have such a V-type figure of b to the power of a, which is equal to b to the power of a of S of theta, then we can do the Yoneeda correspondence to find the kind of corresponding arrow. And we can use the action lemma to write that arrow as theta underlined after h of s. That's going to be an arrow from hom v comma blank to b to the power of a. Now, since we know that h to the power of s, we can now write as s under arrow. We can rewrite this arrow as theta under arrow after s under arrow. But then we want to see what it corresponds to in terms of a sort of arrow from hom v comma blank times a to b, because that's really the sort of level that we can really get our hands on this kind of stuff. So so basically, to get from this line to the bottom line, we'd sort of want to do the anti-transpose of this kind of arrow from hom v comma blank to b to the power of a. So we're interested in what's the anti-transpose of theta under arrow after s under arrow. And I claim that this has this form here, that it can be written as the anti-transpose of theta under arrow after s under arrow times the identity arrow of a. And this is nice because, like I said before, it's this kind of stuff that we can get our hands on, this kind of theta under arrow anti-transposed. And so we can sort of get something like that and just do it after S transpose times the identity arrow of A, and that'll give us the kind of thing that corresponds to doing the kind of S action on this theta in the exponential object. But we need this equation. We need to understand where this comes from, why these two things are equal. So let's do that. So firstly, let's think about theta under arrow after S under arrow. You can see I've drawn it here. This composition is just an arrow from hom v comma blank to b to the power of a. So now let's take this diagram here and let's times everything by a. So we get this kind of stuff going along and going down here. So we have s under arrow times the identity a is an arrow from hom v comma blank times a to hom e comma blank times a. And then we have theta under arrow times identity a is an arrow from hom e comma blank times a to b to the power of a times a. Now let's just do an evaluation arrow after that, because it's always tempting to think about what happens when you do an evaluation arrow when you have this kind of object, and that's going to get us to b. Now notice that e after theta under arrow times the identity is in fact theta under arrow anti-transposed. And so this whole path going along, we could write it as theta under arrow anti-transposed after s under arrow times the identity at a. Now, if we just want to compose all the orange arrows, we see that this is equal to e after theta under arrow after S under arrow all times identity A. And that's clearly going to be equal to the antitranspose of theta under arrow after S under arrow. And so left-hand side equals right-hand side. That gives us this equation here that we are looking for.